Thank you all for coming. I know that some of you still have grading to do, so I think please hit the 5 p.m. Deadline if you haven't finished the grading. Somehow, don't tell me how. So my hope today is to give you an idea of sort of a way I've been thinking about research the last few years with a couple of examples. And when Shelley emailed me to ask for a title, I thought I'd sort of get you to think about what I'm talking about as an example of a way to search for problems, explore problems, and along the way, get you to think about one way one can think about supply chain research. Okay. Now, after I put this together, I realized that there was a little arrow that I wanted to add. And that arrow is actually the difficult part. Okay. It's easy to think about, well, I got motivated by this example and I wrote a paper. What's more difficult is the reverse. And the reverse is, why should anybody care? Okay. And how did it impact practice? So I'll tell you my efforts in that domain and fess up regarding the limited success on that domain. And the logic being that, I'm trained as an industrial engineer and a mechanical engineer, but we sit in a business school. So there has to be some way in which this impacted somebody. And at least I'll tell you my efforts to try to get this to impact somebody. So what are the two contexts I want to talk to you about? I want to get you to think about two contexts which are very different from each other. And one is sort of distributing and selling through small stores. And I'll define that in a minute. So think about one context. And the second is evaluating the economic value of technology being sort of developed at national labs. So two different perspectives. And what I'm hoping to do is to take these two perspectives and give you the supply chain angle associated with it. Hopefully, I'll give you an idea of what data, how we got started, how we tried to characterize the problem, what we did to write a paper, what we learned, and finally, who it impacted. But before we begin, I want to sort of think about, so who would care in each of these two contexts? And so in the first context, my goal is to help a manufacturer who's distributing through these stores to reach a customer. So my goal is to provide something that might provide input to that manufacturer in writing a contract. And I'll specify what I mean by that. So the answer would be, here is a way for you to think about a contract to get this work to happen, and all of the rest of it will get clarified. In the second example, it's to assist the Department of Energy to get an estimate. Here is a researcher in a lab doing experiments, reporting their experiments, and the Department of Energy is being asked to say, well, so what will be the value? And obviously, you know that if it's research, there's a lot of uncertainty associated with outcomes. So there needs to be some way to evaluate the value. So these are the two sort of people who would get the answer. So when my arrow goes in the other direction, is to see whether I can help one of these two. So that's the general plan. So we'll see how the time goes. So the first example context is sort of retail trade. And here's sort of a little bit of data. So if you think about what retail trade looks like, is in many countries, in India it's 12 million small stores. In China it's about 6.8 million. And overall there are 50 million small stores. And that's where you go to buy things. Okay. So what are these things or products that I'm talking about? The products I'm talking about are sort of everyday things, toothpaste, tissue, chips, soda, etc. Everybody goes to these small stores to buy stuff. Okay? They wouldn't drive to a Walmart, they would go to a small store. And these would be classified in the literature as FMCG, fast-moving consumer goods. And so these are the things that people. Now, what is the idea? The idea is the inventory of the product is close to the customer. And actually, you can get delivery within 15 to 30 minutes. In fact, all you need to do is walk a few minutes, buy what you want. And in many cases, you can call the person and they'll come deliver it to you. So when you think about next day delivery, many of these people say, what do you mean next day? We get it in 15 minutes. So this is so when you think about these developing economies, the expectation is that you're going to get everything in 15 minutes. Okay? Now you might think, well, yes, you can get it for 15 minutes, but how much do you pay? Well, in many countries, there's a manufacturer-suggested retail price on the product, and everybody pays that price. So pricing is not an issue. So all that is required is, now of course, this manufacturer-suggested retail price is an upper bound on the price. You can sell it at any price you want. But most of the time, that's what you're paying. Okay? Except very recently, and I'll get to that in a minute. So most of the time, that's what you're paying. So really, it's not price competition, it's convenience. So whoever can get it to you quickly at that price is the person you shop with. Okay? So that's sort of the context. And this particular group has been studied. There's a recent book that came out from the MIT Press, and they call these Nano Stores. Okay? This is by these two authors. So the question to think about is, so how do you model the logistics cost to distribute through all these stores? And at first glance, I was at various conferences where people would say, this is inefficient. This is just a transitory phenomenon. What's going to happen is the Walmarts and the this one, etc. are going to come in. All these people are going to vanish, and we're going to get these big hyperstores. And surprisingly, that hasn't happened. Okay? Various attempts to sort of dislodge these groups haven't worked. And so the question that was interesting is, how does one understand, what the logistics cost is? So if you want to sort of look at pictures, here's a way to sort of think about the problem. So this is a little supply chain picture. And that is, you would say, well, there's an OEM. There are a whole bunch of little stores. And people would come to these stores to buy things. And notice that the job of each one of these stores is to have what you need, because if they keep calling you and you don't have it, they're going to shop somewhere else. So the goal of each one of these little stores, which is owned by a person or an entrepreneur, is to have a sense of what people need, the mix of products, and the volume. So most of the time when you call, the product is there. The question is, how does this OEM manage this? And it turns out that there is a person called a stockist, an entity called the stockist. And what does this person do? They do the following. They get product from the OEM, they distribute it to everybody, and the question you're asking is, how do I contract with the stockist to do all of this work? Okay? So what is this work? I'll define it in a minute, because part of what we had to do is sitting in my office, I don't know what they do. So we needed to figure out what these people do. And so what they have to do is somehow get the product to all these little stores so that people can, when they call, they'd get the product. So this is the supply chain. So we wrote a paper on this, and this is basically what I'm going to talk about. I'm going to talk about the stockist, how we learned about what they did, what we plan to do, a little modeling, some analysis, etc. So again, this is the starting point. The expectation is that small store retail is expected to remain a dominant portion of retail in India. The key is this last part, which is sort of useful. Yes? I'll show you a picture in a minute. Okay? So, in fact, let me show you the picture first. This is what a small store looks like. Okay? So this is a store in Morocco, Colombia. You'll see stores all over the world. And what they would carry is a bunch of things. So you'll get some water, fresh bread, a bunch of things, toothpaste, etc. And the mix of things they carry will be the mix of things most people need. So they'll adaptively adjust to see what is it that people in this neighborhood need, what brands do they need, etc. And they'll carry those brands. And in fact, they will, in some sense, if they're being asked for requests, then what they carry is what people would buy. Okay? So this is a small store owner. And the small store owner actually is, on the one hand, you might do all of these things, and they're probably true. They do not have up-to-date point of sales technology. They may not have sophistication, all of those things. And you think, well, how are they surviving? They're surviving because they're adaptive, and they're talking to you. And because they're talking to you, they're adjusting what they carry. And in some sense, everything we do is just basically about gathering that information, being adaptive, and carrying the right mix in order to be competitive. Because remember, if they're not competitive, it's game over for them. Now, what's interesting is that they've been around for hundreds of years, all these small players. Yes. No, they're not clothing stores. Fast-moving consumer goods. So toothpaste, paper towels, potato chips, things of that sort. They're not clothing stores. I mean, clothing store is a different animal, but I'm not studying clothing stores. So,
regulation about opening?
No. Yeah, you can be open however long you want, and
Can somebody set up business right next
yeah, absolutely. Nothing prevents anybody. Many of the cases what we might have is for a smaller people, smaller stores, they may live at the back or live at the second floor, which means anytime you need, even if they're closed, you knock and somebody comes down and allows you to buy things. So it's really completely unregulated. The only thing that in some sense is, whether or not you can make money. Okay? If you can survive, make money, and people shop, you're in business. Okay? Now, remember, real estate costs are not low, so therefore there's that little barrier. Okay? So this is an example. This is an example from Blanco and François. And in this supply chain, really, there is a person here. So the logistics is there's a warehouse person who comes, who supplies each of these people. There's transacting. And surprisingly, unlike what we would like, I'd like the operations problem to be separate from the marketing problem, to be separate from the finance problem. Everything comes together. Okay? So let me tell you what I mean by that. So what we had to do is say, well, what is this problem? Remember, my co-author is Professor Omkar Palsule Desai. He teaches at the Indian Institute of Management at Lucknow. So the good thing is research can happen after 10 p.m., which means the day is available to do everything around here. And late at night, you can work with a co-author. Okay? So one of the questions was, what do we know about these stockists? So my first thing was to do a Google search. And I realized that none of the business school faculty in India care to study these problems. Because they say, well, we want a publication. Nobody else is publishing in this area. We're not going to study it. So how do we study it? So the good news is, I said, well, can you get your MBA students to actually travel and record what people do? Okay. So he said, okay. He got a bunch of students, probably gave them some independent study credit, and they went to 243 on-site visits and just wrote down what happened. So the person shows up. What does he or she do? Okay. Now, if you take, so we have all of that data. Now, remember, this is not my training. This is the kind of training that anthropologists and other people would do. This is not my training. Nevertheless, I can count, I can do distributions, and figure out what are the main things they do. Here's, of course, what you would expect. First is they process orders. How much was your order? How much am I delivering? The stockist. So the stockist is the person who's visiting the retailer, and the transaction is managed by the stockist. So this stockist, the first thing they do is order processing, how many units of each of these things. Physical distribution, I remove it and give it to you, put away. If I'm going to take a case and divide it into individual units, I do that. Third is marketing and demand generation. So part of what you convince this person is you say, well, you used to carry this. I really think you should carry this because it's selling better. Okay? Now, this is a part where you're basically helping with merchandising. And you're helping with, in fact, market share generation is all this person's ability to convince this player whose constraint is, I only have this much space. If I carry your product, I'm pulling out somebody else's product. So who do I pull out to give things to you? So that's the third. The fourth is managing working capital. Most of the small retailers do not have a bank account. Nobody's going to lend to them. The person who lends to them is the stockist. Okay? They basically say, here's goods on credit. I'll pick up the money when I come back next time. Tell me what you sold. Pay me based on that. Okay? So the working capital is not coming from a bank, but it's coming from the stockist. And finally, after-sales service. There are many manufacturers who would say, any problems, any damages are not my problem. It's your problem. The retailer cannot handle those things. The stockist says, don't worry, I'll take it back. I'll find some other market for it. Okay? So this is what a stockist does. And if you think about all of these things put together, you see that there are like 3 sets of things. 1 and 2 are the traditional, what we would look at in ops, routing, delivery, inventory. 3 and 5 are what marketing folks think about. And everything associated with financing is obviously handled. by finance. So it's three different roles being played by the same person to keep the goods moving. Obviously, you need the money, you need the inventory, and from the point of view of the OEM, you need somebody to push the new products and replace the old products. And if you want to gain market share, you want to elbow out the competition and carry this product. And this is the role of the stockist.
More than one stockist call on each of those.
One stockist for each manufacturer. Exactly one. So there are sales territories assigned, and there's one stockist from each manufacturer. So the P&G person will be one P&G person for a set of categories. That's the only person who will come to you. Okay, that's managed by the manufacturer actively. Okay. Now, so the main question we said is, so what are the margins? What are people getting paid? Now, this is the part which you don't get from anywhere. And I'll sort of fess up as to how we got it. So the first is my co-author graduated from the Indian Institute of Management at Ahmedabad. It's a premier institution, and many of their graduates are the current vice presidents, et cetera, of these stores. He just pulled up his alumni book and called them. And they say, off the record, we'll give you all the information. So this is off the record, all the information from the bulk of the players in the industry. And the key thing to note is, look at those percents. That's what the stockist gets paid. Okay? This is the percent of the selling price. Now, when I saw these numbers, they are much lower than any number I've seen anywhere. In class, when I teach logistics, I say, in the absence of data, think 15%. Okay? But look at those numbers. So look at ITC. Somewhere in there is ITC. That's a cigarette company. That's 1.45 to 3%. That's what they do all this work for. Look at HUL, that's Unilever, 3 to 8%. P&G is at 5 to 10%. So one of the numbers that was curious is, how is all this happening for such a low margin? And it's very competitive to become a stockist. And so these are the numbers. So the secret to the success for OEMs to distribute and keep all their inventory, et cetera, is somebody is willing to do it. And I'm going to show you, they make a lot of money, even at these margins. Okay? So this is what is interesting. Now, the other thing that happens is, the question I'm asking is, how much should an OEM or a manufacturer contract to pay a stockist to do the work efficiently? And what efficiently means, et cetera, I'll sort of clarify in a few minutes. Okay? So this is the part which, we were the first to collect this data, but one of the things that's a puzzle is, how is this happening? Now, of course, pretty soon I'm going to try to translate it into slightly more standard vocabulary, because nobody would care if I told a story. So I've got to convert it into some mechanism where I can do some math, do some analysis, et cetera. So one of the things you also notice is that the stockist is not sort of left to do all this by themselves. They're actively managed by the manufacturer. So the manufacturer does step in and provide them some help. And we sort of try to understand exactly what help each person provides. The help might be in the form of, I give you software, I give you point of sales, things for you to collect, I give you a tablet, or I can help you buy trucks. I can do a whole bunch of things to help you out. And what I'm going to quickly say is, I'm going to convert this help into one of two categories, complements or substitutes, and I'll sort of get you to quickly think about what that is in a few minutes. And at the bottom, there's a whole bunch of details of very specific kinds of support that's provided for them to do their job. So let's sort of switch gears a bit. So this is my summary data. And the summary data says that if you look at the margin, it varies between 2.2 and 9%. And there are different types of relationships, whether there's substitutes or complements, and some of them provided very little help, many others provided a lot of help, and that's all you need to look at in this table. By the way, whenever anything flashes up on the screen, just look at what's in yellow, ignore everything else. Okay? This way, there's a lot of other stuff that you don't need to care about. So here's my question. Can I explain this? Okay? So if you give me a problem, if you give me a manufacturer with a bunch of products and a region, can I crank through something out of which will come a contract? And then to validate, can I compare those contracts with the contracts being written And can I explain some reasonable aspect of it? So that's my challenge. Okay. With the manufacturer and the stockist. Okay. So that's the contract. Now, the kinds of context-specific information you would have is where is it located? What is the store density? And a few other things that will characterize. And what I'm hoping to do is to give you a sort of a very parsimonious set of 3 values and say these 3 values will allow me to give you a contract. Okay. I'm going to try to give you some proxies for it. So that's the general problem. So here's our approach. Some of it, many of you in the room will recognize as standard. We have to adapt it a bit. So I'm not going to claim that we did. The first is we're going to use sort of a principal agent model. And you might ask why. And that is because the agent, who's the stockist, really is succeeding because of a combination of their things. Their ability to do their work is a lot more efficient if the retailer trusts them. Okay? Because they could basically say, just drop everything off, give me a bill, go. Why? Because I trust you to do the right thing. Their ability to be successful in getting you to carry new products is a function of them, oh yeah, you wouldn't stick me with bad product. So, I'll take your advice. So there's a lot of detail that's the capability, if you will, of this agent that you're not quite sure. Will they be good at distributing my product? Will they know a lot about this? So a lot of that, so I'm going to sort of frame it as a principal agent model in which I, as a manufacturer, don't know for certain the capability of my agent, but I have to write a contract. Okay? So that's the structure. The only thing I'm going to add here is that I have the ability to change the dynamics a bit by actually providing some assistance based on the nature of the relationship between my help to them, whether I give them point-of-sale terminals or software or other things, and their cost efficiency. So I'm going to I'm using that as my sort of building block. So there's information asymmetry regarding capability. Now, what I need to do is to now build a more detailed model of the cost structure. And the cost structure comes from this individual agent's ability to actually travel, distribute, collect money, etc. So that requires me to build a sort of a routing model and an inventory model. And then I'm just going to consider a couple of relationships between the assistance I provide and the impact on the cost structure. So when we're done, here's what I want to get you to think about. 3 parameters. Okay. One is the impact, the ability, the routing efficiency. Okay. Now, here's an intuition. If, in fact, a lot of the stores are located close by, almost anybody can be efficient. Just go down the street and distribute to everybody. Okay. So if there's a high density, getting routing efficiency is fairly easy. But if there's low efficiency, then getting routing efficiency is more difficult. But actually it turned out that it's not just traveling, it's also transacting. So what I'm looking at is time. So it's not just you can travel to all the points, but when you travel to that point, how long does it take you to transact? That is to collect the money for the last transactions, deliver the new ones, sell you new things, and the greater the efficiency of relationship, the faster you can do it. And speed translates into efficiency and money because you can do things much faster. Okay? So that's the lambda term. The second is a rho term. And rho is your ability to impact demand. So your ability to actually grow the market. And this is a function of your ability to convince this retailer to start carrying all these other higher margin products for which there's a market. And finally, the third is, in some measure, it's your measure of how well you know the capability of the stockist to sell your product. So here's my claim. If you give me these 3 parameters, I'll give you a contract. Okay? So that's our claim. Now, why do I make this claim? So for the next few slides, I'll just show you how I make this claim. Many of you would know that, well, first let me give you a little definition. So many years ago, Lee Schwartz and I, working with Stefano Zenios, had done some work with Ford Motor Company. At that time, we used a model which actually turned out to be very useful for this context. And I was trying to sort of figure out the easiest way for you to think about the second cross partial, and I thought this picture would be a simple way to do it. Okay? So in this picture, what you have is, in that example, think about cost, and this is for this stockist. Okay? And think about capability, with the idea being that a more capable supplier has a lower cost. Okay? And think about X as assistance I give this stockist. Now you know that anytime I provide some assistance of any form, it's only valuable if costs decrease. Otherwise, you'll just ignore the assistance I give you. The question is, who gets how much benefit? Okay? So notice if you look at this thing, when I go from x1 equal to 1 to x1 equal to 2, notice what happens. The people with the low capability get most of the benefit. The people with a high capability get very little benefit. In other words, the assistance I give you substitutes for your capability. Okay? So you might ask, should I do this? Well, notice that two things happen. In this particular case, it's a good thing because when I give it, of course, there's a cost, my cost to provide this, which has to be taken into account. But if I give this kind of an assistance, what I've done is basically decrease the difference between the types. So what I'm really trading off is assistance I give you for what in sort of principal agent model parlance would be information rent. So that's the trade-off. What I have to do is ex ante, based on the information about the market, all I can do is to offer contracts. And then people will choose, and off we go. So I'm not looking at the repeated game. So I'm just saying I'm offer the contracts, people perform. The next time I have to contract, I may know better, so then I'll be in a different state of the world. So I'm not solving the dynamic program of what the contracts will be. I'm just basically saying, I have to contract now, this is what I know, I'm going to write a contract for this duration, which may be a year or 2 years. So that's, yeah, this is a one-period model. Okay? So each time I'm solving a one-period model for the duration of the contract.
So who decides the market coverage?
Yeah, so that is chosen by the manufacturer. So the manufacturer the manufacturer announces sales territories and then contracts for that sales territory. So that's the way it's operating. This is a model with substitutes, but there's an alternate model that's also possible. And that is that the kind of technology you provide can only be leveraged by the high capability supplier. If that's the case, then it's a different kind, because what it does is the good get better, the bad just remain where they are. Just notice the nature of the curve. So this can be thought of as, in order to take advantage of what assistance I give you, do you already need to be good? In other words, do you already need to have computers, etc., for my software to be used? All I do is provide software assistance. It's a bunch of people who don't have a computer. The software assistant doesn't help them. But the people who are already efficient get a benefit. So these might be thought of as two different ways you can characterize assistance. So let me get you to think about a few things I need to think about. So these are all the things I need to worry about. Routing, truck capacity, capability, cost structure, stockist's impact on store demand, which I'm going to characterize as my rho, because you can actually influence store demand based on your capability. Demand at the stores and delivery frequency is a choice based on the contract that's offered, and profits. Okay. Now, all of this is from the perspective of the stockist, but the contract is being written by a manufacturer. So the manufacturer takes all of the stockist decisions and then says, well, this is what I know. I may need to pay a little bit because the better types have to be incented to behave based on type, and I'm going to solve for the optimal contract. So that's the next few slides will flash through a bunch of some related math. Just look at the thing in yellow, ignore everything else. And so here's what will happen. So the first thing we need, which is actually a very interesting problem, is that the building block for a lot of this is that when you're routing, problems become easier when there are more points to route. Okay? In fact, asymptotically, the cost structure grows as square root of n. This is a very famous result from a lot, even before this, and this particular group made it so that you can look at capacitated routing problems. So the short answer is, even though there's some complicated combinatorics, the cost structure grows as square root of n. So if you say, why do I care? This actually matters, because then the cross partial should go in the right direction. We're going to have a particular description, which is just, again, nothing in yellow, but just realize the effect of a higher lambda is that it becomes easier to route. That's all. Okay, higher density of stores means I don't need to give you much assistance. You can route efficiently. Okay, just. This is a demand process, and that is rho, which is a parameter. And you can think of it as if, in fact, the market is already saturated, then you wouldn't be able to influence and grow the pie. Okay. So if the market share is only at 70, 80%, yes.
When you say grow the pie,
Yes.
talking about
The manufacturer's demand in the sales territory.
the store has a fixed area,
Yes. Yeah.
so you're pushing something off the shelf.
Yes. Yes.
And ultimately, it has to be purchased.
Yes.
Are you affecting the purchase likelihood?
So yes, so what I'm doing is the following. So imagine there is this region. In this region, there are a bunch of people who shop in all of the stores that I supply to. What I'm trying to do when I say grow the pie is I'm Unilever. I sell toothpaste. So I want to grow the sales of toothpaste in this region. That's what I care about. Now, the way I grow the sales region is I give it to the stockist, who gives it to the retailers, and he somehow convinces the retailers to peddle my toothpaste, as a result of which my sales grow. So what I'm basically looking at is there's a parameter which says what is the market potential, if you will. So if I'm already at 80% consumption by people in this region, there's really not that much this guy can do to grow. But if I'm in a new entrant in the market, there is the possibility that he can help me grow. That's my parameter rho. So rho sort of gives me a sense of where is the leverage. And so how that leverage is executed is through the capability of this stockist. Okay, so this is a functional form. And finally, we need some cost structures. Okay, so what do we need to do now? I'm just going to flash a few equations just to get you to think about the following. The stockist problem, look in yellow. Basically, once I know how frequently I'm going to visit or my cost, then I'm going to solve an economic order quantity like delivery schedule. Okay. What that means is that I'll optimize. It's in my self-interest, given that I'm going to visit, given that I have a cost structure, the frequency with which I visit is going to trade off my cost to visit and the working capital. Because remember, I collect my money during my next trip. I deliver the goods now, I collect my money during my next trip. So if it costs me more, then I'm going to do the trade-off, which is the economic order quantity, to figure out how much to deliver. Okay, so this is this. Now we solve the firm's problem. So all of this gets rolled up into a firm's problem. And notice that the firm would anticipate all of these things. They would anticipate your cost structure. Notice it's a pretty competitive environment. Lots of people trying to be stockists. You have some reservation utility. We'll do all of these things. We'll solve, and out will come sort of a menu of contracts that they'll offer. Everybody will choose based on their type. Okay, so this is what it is. So there's a lot of little detail, but don't worry about it. And here are the contracts offered, and here's a substitutes case. Okay, so now we're done with a whole bunch of math. Some of it is standard, some of which is customized because of the nature of the functions here. Okay, done. So what did I want to do? By now you would have seen a bunch of things flashed by. So we're back to the same three parameters, lambda, rho, and nu. So what do I want to think about? First, I'm just going to show you a few graphs to just get your intuition going. And so the thing you might ask is, let's just have what happens if the routing efficiency increases? So we can intuitively say, well, dense clusters means stores can be covered more easily. Okay? So you can cover more stores in a trip. So since you can cover more stores in a trip and you're more efficient, you could go more often, right? And when you go more often, the delivery to the next trip will be smaller, more frequent deliveries. If you have more frequent deliveries, your working capital requirement is smaller. So you're going to go back frequently. You're out of pocket just a little bit. Therefore, lower stockist costs. Okay. Now, of course, the manufacturer knows this. The manufacturer is writing the contract. So they'll extract most of the benefits. And what will they do? Give you lower margins. Okay. So if in yes?
Is the manufacturer giving the stockist a menu?
Yes, 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 yes. And so the menu is the output of the solution to the principal agent model, and it gives you, I mean, the answer is a menu, and the menu satisfies the revelation principle that people will choose based on their capability. And built into that menu is sort of an information rent, which is an incentive for the better type to basically behave like the better type. So all of that is built into the solution to that model. Here are just a few pictures. So holding everything constant, the dotted line is higher density, the solid line is less density. Just notice which direction the line is going. Okay? So what do I mean by that? Let me just pull this up. Notice that assistance goes down if it's easier to route. Working capital goes down. Margins offered to the stockist go down. You know, I'm going to skip this, but this is basically the financing cost goes down. And if I now look at, I mean, this is all this is. So the difference between stockist goes down and the manufacturer profits increase. So if in fact it's an easier problem, the model is automatically set up so that everybody's behaving optimally, some of the value is being extracted by the manufacturer, and you get a solution. Okay? So that's all we have at this point. So now you might say, so what? Because you might say you could have dreamt all that up sitting in your office. You know, why are you telling us this has anything to do with anything? So the first thing was to try to apply the model to context where we can actually characterize the space, characterize the density, solve for the contracts, figure out all the details so you can compare it to what might be a reasonable representation. So suffice it to say we did all of that. The more important question is, well, remember at the start I gave you a bunch of contracts? You might say, can I recreate those contracts by just using proxies for the parameters I told you? Okay? So what are proxies? You might sort of get, I mean, clearly if you say urban versus rural, of course, depending on the location, our data set was in India, so you can look at urban stores, retail, rural stores. Every store has to register, so it's not that you just open up. For you to be a store that can actually sell, you're registered, so there's a directory. So we know every store today. If you look at a map, a Google map in every street, it will tell you the store, their license number, etc. So you can record that. So you can get an idea of density of stores, blah, 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 etc. So we can think about the following. We don't know how firms came up with their margins and the assistance, but we can use proxies to come up with contracts. And we can ask, hey, how reasonable are these two? So we sort of divided it into some segments, and you can test that statistically, there's a statistically significant relationship between the contracts we came up with and the actual. But I don't want to oversell this. And the reason is because I only have 17 data points, okay? So I don't want to get carried away with this. This is the data I have. I can get scatter plots. I can see directionally what is happening. Okay. So now one thing you might say is, well, why should, yes? So the data point I'm looking at is the margin and assistance that my model will generate, and the margin and assistance that's currently offered by the 17 firms, which cover about 80% of the market. And that's the 17. And I'm comparing the XT that I generate, the XT that they offer, and I'm trying to see how close they are. Okay. So statistically, I can say we're sort of in the ballpark. But then somebody said, well, why should I believe your proxies? Right? I said, okay, what if we went to that list of people that we had, and we asked them to say, hey, for each of these firms, what is your guess regarding their location in these dimensions? Now, it actually turns out that, they're not the greatest because they don't know enough about other firms, but you sort of get reasonable, even if you use their input and you didn't use your proxies, you sort of get results which are reasonable, okay? They're in the ballpark. And what do I mean by that? It just means that if you're a new manager who goes into the country, crank this up, it gives you a suggestion, use this as a starting point. That's all it says. It doesn't say use this as the end point, but use this as a starting point. Okay, so we can get some statistical results. Now, the interesting question was, how can I actually so this is a validation question. So here's a story. I'm going to tell you the story and see how we can use the model to explain the story. So Procter Gamble India has had a very difficult time. P&G has had a very difficult time in India. I think the Indian market contributes about 1.5% of their sales. as compared to Unilever, which is a very dominant player. And P&G's had a very tough time breaking into India. So one of the things they did is they came up with a project called Project Golden Eye. And this is what they did. They basically said, okay, we're going to retreat from all the rural markets. We're only going to focus on urban markets, and we're going to decrease all of the assistance, decrease X, and we're going to narrow our focus to just basic products. Okay. So the question is, yeah, they're going to decrease the assistance, decrease the margin, focus on basic products. That was their announcement. So the question is, does this make sense? So here's my way to explain it. So imagine that you take different combinations of ability to generate demand. So if you're looking at basic products, then your ability to generate demand for those things is not very high. But if you are in an urban market, then it's very dense. So what I can do for different lambda row combination, I can generate an ISO profit curve. And so here's a way to sort of think about what happened. They decreased variety, that is focused on basics. They focused on urban markets. And the question is, can it increase profits? So here's my thing. Start with this point, 1.2, and that, where the vertical line is at 1.2. Move to the left, okay? Decrease variety. Increase density. Notice that as long as you cross that point P2, you can be more profitable. Okay? So there is a logic to sort of think about how this might be a combination. Now, in this combination, you might ask, why is assistance decreased? It's a simpler problem to solve. It's in a more dense territory. The benefit of providing assistance is lower. So basically, all of that is what you would optimally do if you change the nature of the market. Okay? So this is what it is. So what did we claim at this point? I've claimed that these three parameters help. They can help understand. How many people can I efficiently distribute? So now I want to get back to this question, which is a more nagging question. So let me quickly talk about, practice to research to practice. Now, of course, there is this question. First of all, no journal cares about this last part. Okay? I'm not a consultant. So what can we do? Well, actually, it turns out that you could share this with the original managers. We have already used it. It actually turns out that there is a conference in which there's an opportunity for supply chain researchers to sit down with executives from P&G. This is a small conference of 25 people. 5 of us sit with 5 people from P&G, and they basically, so what are you guys working on? So I said, oh, funny you should ask, because one of my chapters is on P&G in India. So what I've done is send it to them, call them on the phone, tell them everything. They haven't told me whether they're using it or not. Okay? So I don't know. The third is, we had a contact in Peru. There was a company in Peru distributing in India. I said, hey, do you want to know about stockists? Here's a paper. Okay. What's interesting is that now things have changed, and this is more recent. It actually turns out that the last mile problem in India is horrifically complicated, because the directions are drive till you reach the tree, take a right at the tree, you'll see a sign, take a left at the sign. It's a very difficult problem. So guess what Amazon decided? Amazon decided we'll deliver to the small stores, pick it up from there. And we'll pay the store a fee. Okay? So there's actually a very interesting problem brewing whereby everybody is used to getting things. Perhaps it'll take longer, but rather than dropping it off in your house, so it actually turns out that there are 3 main players. Amazon is competing with Walmart in every one of these locations, and there's a third local manufacturer. We have a little paper going trying to understand this thing. But actually, the fourth one is what I find interesting, and this is what I use in my exec ed class. So I want to get you to think about the following. What would you prefer? Getting in your car, going to Walmart or Target, filling up your car, coming home and carrying inventory? Or every time you need something, walk 5 minutes and get it? Or pick up the phone and call, and somebody gives it to you in 15 minutes. So my guess is that we're going to turn around full circle. It's just that rather than small stores in a US market, it would be too expensive, Amazon Go stores will show up. Okay? So what you do is take your smartphone, open the door, pick up what you want, and leave. And Amazon's plan is to flood the country with lots of stores with no human beings, with a bunch of inventory that's customized to what you want. And how that inventory is customized is really an algorithm replacing the shopkeeper who was trying to figure out what you want. And if you had that, that would be a lot easier, right? Now, of course, the question will remain, who will stock these machines? Okay. By the way, I was at a conference in Los Angeles and went to the lobby of this building, and there was a little store. And he said, hey, I'm a little store. Just flash your, download this app, open this, and whatever you need, toothpaste, toothbrushes, this, that, potato chips, etc., is in there. It's like a vending machine, but it's more adaptive to what people want, and the sizes are adaptive. So if you say, why bother studying these problems, it's quite possible that retailing will be this problem. Okay? So what started off with a lot of people and a lot of labor could get replaced by a different sort of model. Okay? So this is my part with respect to practice. The game's not over. So I have about 7 minutes, so I'll give you a quick summary of the second problem, which is a little different. So I'll give you the sort of the fast version of this. So this problem is actually very interesting because it's a completely different context. The very first word says OSTP. This is the Office of Science Technology Policy. And so there was a very interesting report that was released in 2010 by the Office of Science and Technology Policy called Critical Material Strategy. Okay? And critical material strategy basically talked about all the materials that are key for the kinds of things that the Department of Energy sort of mandates or encourages, etc. So wind energy, solar, electric vehicles, LED lighting, etc. And what's interesting is a whole bunch of new materials have become the source of risk. And so this is neodymium, dysprosium, praseodymium, lithium, cobalt, nickel. The first few, those of you who remember your periodic table, it's the little piece that's disconnected from the periodic table that has become really, really important. So for about 7 years, so I'm funded a little bit from them to do supply chain analysis. So what is the issue? So Congress funds basic research. Okay. They say, we're not in the business of doing what industry does. We fund basic research. But Congress, it says Department of Energy does. But Congress says, do basic research that has high economic value. Okay. Now the challenge is, none of the researchers in the lab want to have anything to do with this. The reason they became researchers is to do research. And this is just a chore. Okay? So we are the people who help them with that chore. So what is the challenge? The challenge is that they're working on a variety of ways in which to ease the problem. One is to develop new sources of rare earth elements. Okay? So one of the examples is phosphate deposits that come from fertilizer plants. It turns out that they contain rare earth elements. Similarly, some types of coal effluents contain rare earth elements. Now, there are lots of challenges. Again, a little problem is that if you separate out the rare earths, then the remaining has a higher concentration of thorium, which is radioactive. And so all of a sudden, your costs grew an order of magnitude. So what you need to do is somehow see to it that you extract what you want, but what remains behind is also something that doesn't increase costs. So that's the first. The second is you can decrease the material intensity of these things that are required to create magnets and other things. And that requires the physicists to do a bunch of stuff. And the third is you can recycle. That is, you can take all your hard drives, pull out the magnets, pop them off, and do a bunch of things. So what are a few things you can think about? So let me quickly draw the whole picture, not walk you through clicking all of it, and get you to think about the supply chain here. First, Congress is the one that appropriates the money. In fact, they appropriate it every year, which means even though this is a 5-year grant, every year somebody goes, makes the case. The Department of Energy awards the grant. They've created an entity called the Critical Materials Institute, which is based in Ames, Iowa. We're one of the entities. Purdue is one of the members. And so we get grants from them. The researchers get money from CMI. And part of what they're supposed to do is they're supposed to make the case. What is the value of the technology that I've generated? Now, their problem is, why are you asking me this question? I'm a researcher. When I'm done, I'll tell you. Okay. However, you can't wait till you're done, because whether you're going to get funded this year is a function of what are the odds that you're going to be done? So that's the question. So here's an example of a specific thing. So this is an exchange spring magnets project at Lawrence Livermore Labs. So US windmills primarily use gearboxes rather than magnets. Based on worries of sourcing of rare earth materials from China, the supply risk is high because of China monopoly. So here is the proposed project. If the project is successful, it will relieve supply constraints, reduce costs for magnets. However, the technology is novel. We don't know how to do all of these things. And so, of course, they wouldn't have proposed the project unless they thought it was a good shot. But nobody quite knows whether it's going to work. And their question is, what is the value of this technology? So by now, you would have guessed. I'm going to skip this. So here's a way to sort of think about the problem. At the start, you could ask, hey, what is best case? What is worst case? What do you expect? And most of them can describe it. They're smart people. They can give you a sense of what it is. But the real value is updating as they file their reports. So every quarter, they have to file a report saying, where are you, where are you, where are you, where are you? And the one thing with getting any money from DOE is the constant reporting that you need to do. So as each milestone is covered, researchers provide details. And so one thing you could think about is, hey, I can use that data to update the probabilities that you're on the right track. And therefore, I can basically be contingent based on my decisions. So you can do a little Bayesian update based on the data. And therefore, we're basically solving this problem. What's the expected value of a stochastic dynamic program with Bayesian updates regarding where they get? Okay? So since I'm short of time, here's where all of that has led. So one of the things we're trying to do is to help researchers choose what to focus on. So what do I mean by that? What I mean by that is, look, you can take all of your equipment and focus on this narrow thing, or you can have a fallback plan. And what you learn from this won't win you a Nobel Prize, but this fallback plan will be good enough for industry. Okay? So you can quantify that benefit by getting the value of this expected profit calculation. We can also help the entity, which is CMI, think about budgetary reallocation. XYZ is really racing away on the top end. Should you pull money from one, put it to the other to help them out? That's the second decision. The third decision is there's a portfolio of projects. Each individual project may not give you a win, but across the projects, the industry may benefit. So how do we estimate that? And finally, the Department of Energy announces regular plans in the future, and they say, are we going to get these gigawatts of wind energy, which will require windmills out in the ocean, which has to be these rare earth magnets? Will we be able to attain this? So most of our results have been sort of helping get these things. Now, here's a price to pay, and I want to fess up right off the bat. The price you pay is that the people who want these answers are within the domain. They're not within my domain. Okay? So they're in the Journal of Metals and Energy Policy and all of those things. They're not necessarily in operations. So what's interesting is, yes, you can do something to impact practice, but there's a little price to be paid, and that price is. So here's a quick summary of where I want to be. First is that some of these context-specific research starting points can lead to exciting possibilities. The part that's a little interesting is that the tools you need are a little different. Some of them are more like what anthropologists do. You observe things, you collect data, you hand collect things. In some domains, you guys already do it. In our domain, it wasn't that common. Validation is a challenge, and so I've given you the best we've done on the validation front. But impacting practice is a long game. And in some domains, it might take a very long time. So all you can see is directional proxies. Am I influencing A? Are people using this, etc.? And so the bottom line is it's sort of fun and fulfilling, which is really what the story is about. Thank you.